The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hello, I'm David, and welcome back to the Electronics Inside, the show where we tear down toys, tools and appliances just to find out what's inside. Today I'm going a little bit outside my comfort zone and I'm tearing down a 1995 computer-assisted sewing machine. I have a little bit of a limited experience using a sewing machine. Most of it dates back to when I was at school, some of which is just from my childhood. This one is a little bit special though, as it's wonderfully advertised in its name. This is the computer-assisted. We'll tear it apart, find out what makes it a computer and what makes it different to a normal sewing machine. Let's get started. If, like me, you're a little bit of a novice with sewing machines, or you're just a little bit rusty, I'm going to pull together some of the research I did for this sewing machine. Head over to the Element 14 community and I'll post it there. Start slightly more sensibly by looking at what will come off without removal. This is a nice little accessory drawer that you can put your spare bobbins in. Have a look back. Don't know if this will lift off. No, looks like it's got a screwed hinge, although we might be able to. There we go. Now this is really nice, neat little detail. The cover for the bobbin is actually got a built-in magnifying glass. Sort of slides in, always handy, just when you need it. There's some nice big Torx screws on the bottom, which seem like a good place to start. I'm not sure whether this is going to take the metal plate on the bottom out, or whether it's going to mean I've got to take the case off the top. I've got to say, this is actually quite nicely built. The plastic tabs that hold it together are actually exposed, not concealed, so you don't run the risk of snapping them off when you're trying to do exactly this. Turns out the handle's not actually attached. I don't know why, because the thing weighs a ton, but I hadn't expected just this massive cast chassis all the way around taking all that strain, and I guess for something that's precision like this, that it has to be absolutely rock solid. At least now the weight makes a bit more sense. But yeah, you can straight away see we've got the main drive motor, which in a traditional sewing machine at least drives physically all the mechanical linkages to the offset for the zigzag stitch that drives the dog. Now, we've got at least one drive motor and a lot of cams, which so far is reasonably similar to traditional. I can already see stuck down here some light gates and what appears to be a second motor. We'll have a look. I have a sneaky suspicion I already know what that's for, but we'll try and get to it a bit more later and see what exactly it is. Ooh, just a single mechanical connection to the front with a ribbon to the keyboard on the front of the chassis. Now we're inside. You can see a lot more detail. Got another second motor here, which is driving the linkage for the dog. Yep. Very interestingly, that's not a fully driven motor. That is a motor driving a 60-degree turn. I'll get some more detail on that later when we get further inside. There we go. So we already know there are two motors, and the third one up here, right at the top. Surrender your secrets. Right, hopefully from this position, or this close up, you'll be able to see that if I move the main motor, the dog mechanism feeds forwards and back, and the needle drives up and down. But interestingly enough, if I push this secondary motor down here by hand, I drive the dog on its own, but only forward and back, not its full cyclic motion, so it doesn't go up and down as well. So the dog's synchronized with the main drive, but is drivable by a second motor, presumably by the computer. So that is how it's able to keep the needle synchronized, but also do the detail of forward, back, or incremental movements forwards to do some of the detail. Let's take that off. There we go. Wow, I think we've identified another big chunk of the weight on this thing. That is a very, very big transformer with a couple of quick blow fuses, excuse me. That's power supply is a completely separate module, which is very nice, actually. And very clever in terms of manufacturing. I guess that means that this module, which is very easily replaceable, is the only thing you have to change when you're regionalizing the device. And interestingly enough, this panel actually shows through the bottom of the machine, so you can always see the power supply that's installed with the device without having to without having to uninstall it. So this little daughter board has got a pair of light gates which engage with this on the bottom of the axle, which is part of the main drive. So when I push this main drive round, you can see this little rotary encoder shows 2 distinct phases. And because you've got the gaps, the overlaps open and the overlap closed, you've got direction as well, which trigger those 2 light gates, give feedback to the main board on the position of that main axle and its rotation, so you can tell, because it's quite common when you're starting a thread to manually feed it so you get the needle in the right direction. Actually, on this computer machine you don't need that because it'll automatically return the needle to the upright position, which must be both light gates open. There you go. So I've got a few plugged connections. Let's get those off and see if we can get the rest of this board off. Right, the little mechanism at the top is for winding your own bobbins. So you don't buy bobbins preloaded with thread. You spool a little bit of your thread onto a bobbin. But there's always a mechanism on the sewing machine to wind that bobbin quickly from your thread. So you spool it up, you run the machine and it will reel in. There's always a little mechanical switch that stops the machine going when it's full, which is this little machine here. It's got a little friction drive that goes onto the main mechanism to turn it. And when the bobbin's full, that clicks up. Just noticed on here, you also have a little micro switch on the main board, which must tell it when it's finished. Rather interestingly, I looked up as much as I could on this machine before I started this, and I had details of this being released in 1995, but the date on this board is the 52nd week of 1994. So this machine was probably made between Christmas and New Year 1994 for a 95 release, so possibly one of the early ones to market. Okay, this is the dog mechanism. So this is the bit which actually reciprocates up and down, front and back to feed the fabric forward and back. And it's all largely driven by a single shaft. And I'm kind of surprised that almost all of this is just kind of push fit together. It's only a couple of screws. Then I suppose it doesn't have to be if it's in this very well engineered chassis that's absolutely rock solid. It's extra assembly time, extra parts that can fail and slip and go wrong, so keep it simple, I guess. Let's turn this over, see if we can get the motor out. Motor's a really weird male connection. I guess it's because it comes from the underside of the PCB and actually has to poke up through it there and there to make the connection. I'll have to look up that part number later. Got no details printed on the chassis as to voltage, manufacturer, speed or anything. Really nice rubber grommet holding the motor mount in. All the remaining wiring comes up through the chassis, through some failed but cable retention and tidying. So we've got a feed for the light. There's a 3-pin connector which runs all the way up here to what looks like an accessory jack. I hadn't noticed that in the instructions, but it looks like a 3.5mm jack for accessories that you can have up by the needle. Didn't know that existed. And then finally, we have another motor up here. So this third little flat pancake motor up at the top, you can see as I move it, moves the needle left and right. Mechanically actuated in a traditional sewing machine, it moves the needle left and right between stitches, and that's how you get a zigzag stitch, which is supposed to give more support and also means you can have some sort of flexibility in the fabric, so you can pull the stitch longitudinally along the length of it and it won't just tear the cotton. Whereas in this one, it's electronically actuated by a third-party motor, which means that you can afford to do the detail. You can do basic embroidery with this and it will do the needle left and right decoratively. You can do it left and right to one end of its extreme as it goes down a buttonhole and then left and right as it goes back up the other. It's not mechanically related at all. There isn't sort of that basic relationship with an override like there was with the dog for the needle left and right. There's 4 cores going to it. And based on the positional control that I've seen, I would definitely think that's a stepper motor. There you go, main drive belt and main axle. This main bearing, the one at the back, is asymmetrical. You see, if I roll that around on my finger, it's wonky. I'm guessing that bearing gets used for alignment. So if this axle doesn't sit right, rather than the casting needing to be corrected or shimmed or anything, you can rotate that bearing to adjust its position. It's a really nice idea. Of course, you can't overlook on the far end of the axle, you've got the main cam, nice counterweighted cam, which will be perfectly balanced Though even in the depths of the machine, it still managed to get thread around it. I'm not even sure how you'd get it in there. That must have been a disastrous bit of sewing to manage that. There we go. That is everything out of a 1995 computerized sewing machine. So what we're left with here are all the electronic components, the really interesting bits from the sewing machine. Let's start with the most basic. I mean, we've got the accessory port and the light. There's not really much else to that, so we'll put that to one side. The really interesting stuff is what's left. Now, I've got a pair of stepper motors, one for actuating the needle offset and the other one for actuating the dog override. So if we set the stepper motors to one side, and we've got a big 24-volt motor, which apparently is very common in drills as well. This particular model is being driven at 12 to 24 volts and is sort of the main drive for the whole system. We've also got the main power supply, which is just a big magnetic transformer. Here we have the brains. Now, I'm really interested at the amount of feedback that you receive from this. You've got these two light gates which give you rotational position and direction of rotation of the main motor, just in case anybody's handed it forward or back. On the top side of the chip we've got a lot of capacitors and diodes for the power regulation and rectification. I'm guessing the 4 big diodes at the bottom will probably go together to make a bridge rectifier with smoothing. That would make sense. Then down here we've got 4 integrated circuits which are motor controllers. Now you can see them traces on the back that each pair go towards those 4 pin connections to the stepper motors, which tell me that those are the motor controllers, but they're only a single H bridge. For a stepper motor, you need to be able to make and break 2 in either direction. So yeah, you need 4 motor controllers or high current switches to do the motor stepping control properly. On the rear side, we also have the microcontroller made by Mitsubishi, and you've got a pulse width modulation speed control for the main DC motor. You have the main ribbon cable across here which connects to the blister keyboard. It's just a big matrix. It's really nice that you can actually see the 2 layers on the transparent keyboard there. Give you a good idea if you weren't aware before how they work. If I wasn't impressed with sewing machines before I started, I definitely am now. The electromechanical interfaces are ingenious in a lot of places. The override of the dog in particular, which must use the timing of the light gates combined with a single stepper motor, allowing it to do such intricate and detailed work with minimal feedback and control, is really clever. It's just been really interesting to see how something that must run for hundreds of thousands of hours in industry is so robust. If you have a specific question or you'd like to know more, head over to the Element 14 community at element14.com/the electronics inside. Ask us a question, or maybe even suggest a teardown that you'd like to see. Thank you for joining us. We'll see you next time.